Hey, howdy, hey, you got the Rock Doctor here. Let's talk about the science method and how it applies to everybody in society. So, throughout my teaching career, I've started every introductory level class with a discussion of what is science and what is not science so that people have a better understanding of how the science method applies to them every day and is, as Albert Einstein said, a refinement of everyday thinking. So, what is the science method? Well, it's basically a method for problem solving. You start with a question that can be answered using the method, you gather data, you formulate a model to explain the data, and then you test the model. And others test the model, what's called peer testing. And if it turns out that the model does not hold up to testing, the most important thing is the willingness to reject your model if it is required because it doesn't hold up to testing. And what do? Well, you gather more data and you start over again. The key with all this is that science is not the search for the truth. It's simply the best understanding that we have based on the data that we have at the time. So it evolves over time and we get better and better and better understanding. So one of the key things to me to try to get across to students is that every person does science. This is not something that the nerds did in high school and it's not for me. So the way to get them to understand that is to use an example of the science method applied to an everyday experience, the stoplight. So we know with stoplights that green means go, red means stop, and yellow means go like hell. And this model is based on years of data collection from the time you are turned forward in your car seat. You've been gathering data that this is the case. And so the model goes through years of testing. It goes through peer testing by many other people. And so when you get your driver's license, you have a choice. You can either choose this time tested model or you can believe that red means go, which is not going to go very well for you. So you go with the time tested model. That's the science method. All right. Now that we know what science is, what is not science? Well, it's essentially any question where the science method cannot be applied. So it doesn't apply to your beliefs. It doesn't apply to moral judgments. It doesn't apply to aesthetic judgments, what's beautiful or not beautiful. Science doesn't tell you how to use the scientific knowledge that you've gained using the method. And it also doesn't answer questions with no available data. If there are no data, you cannot use the method because that's the beginning of the method is to use data to formulate a model or an explanation that can be tested. And so one of the important things to point out to people is what is not science so that they can see that there's a place for belief and moral judgment, aesthetic judgment in their lives, but it's just not science. All right, so let's take and apply the science method to a geology problem. Of course, I am the rock doctor, so we got to do some geology here. So, one of the things that you can do with your friends and neighbors or your students is to help them to understand the age of the Earth without ever talking about isotopic age dating and numbers. You can just simply lead them through the science method to get a sense for the antiquity of the planet. So, what do? Go out to an outcrop and gather some data. Have them look at the rock. And so, in this case, you can see that you have layered and folded limestone. with snail and clam and even shark fossils, and that's exposed at the surface. This is a fold out near the Block Mountain area in southwest Montana in that picture on the left. All right, so what's the hypothesis? What's the model? What's the explanation? Well, the rock accumulated as lime sediment on the ocean floor. It was buried and cemented to form rock. It was deeply buried and heated and folded by compressive forces, and possibly from a tectonic plate collision. After folding, it was lifted towards the surface, and thousands of feet of overlying rock were removed by erosion to allow us to see it at the surface. And so as a result, we can conclude that the Earth has to be very old. So what's the test? Well, today, Montana has no tropical ocean, so environments have changed. On our time scale, lime sediment does not turn to rock, so it must take great amounts of time for the sediment to turn to rock through burial and compression and cementation. Then folds form slowly in plate collisions at great depths. This can be determined in a lab environment, and we're talking greater than 10,000 feet, and pressures of 180 megapascals or higher. That's where the rock is hot and pliable. So that happens today where plates are colliding with one another, and that happens at very slow rates of about 2 centimeters a year. And to see that fold at the surface means that the land was raised and overlying rock was removed by erosion. And that eroded rock can actually be found out in the gravels in the adjacent valley. So that's evidence that the rock was once there in the mountains. And then finally, let others go through the same process, peer review, and see if they also conclude that these processes take great amounts of time and that the Earth must be very old. And so this is a great application of the science method and the ability for people to use their own observations to conclude something important about the Earth, that it's old. All right, well, hopefully that was of value to you and that it provides you with some tools that you can use to help friends and neighbors and students, if you're a teacher, understand the science method and how it is something that applies to everybody. We use it every day, and it's just a way of thinking and solving problems. All right, till next time, thanks for tuning in to Montana Geology with the Rock Doctor.